Hello, everyone. Welcome to the 22nd episode of DevStandup. Today we have Andre Faria as a guest. Andre is a senior solutions engineer at HashiCorp based in Milford, Connecticut. He supports large financial and healthcare organizations on the cloud journey. Prior to the HashiCorp, Andre was a senior technical account manager at AWS and also spent most of his career as a cloud or platform engineer at companies such as Subway and People's United Bank. So today he was going to talk about the Terraform search. So let's just dive in. So Andre, the floor is yours.
Yeah, thanks for the introduction, Ali. Hey everyone. So, like Ali mentioned today, I wanted to kind of dig into Terraform, but more through the lens of, not just only provisioning new resources as, people mainly use Terraform for, but, understanding, governing, and, modernizing existing infrastructure that you already have set up throughout your entire cloud estate, throughout your organization, right? Um, Terraform has always been an excellent tool for greenfield infrastructure as code deployment, but I mean, reality is for most organizations and pretty much all the organizations that I've worked with in the past, um, they aren't starting from zero, right? They already have years of cloud infrastructure created through, consoles, ad hoc scripts, one-off automation pieces, whatever you want to call it. Now, what's new in Terraform and what we'll focus on today is really Terraform's new capability introduced in version 1.14 called Terraform Search. And we're going to dig into, how it helps close the gap with what we call these, brownfield infrastructure landscapes by finding unmanaged resources and bringing them into your Terraform code. So, yeah, like I mentioned, before diving into the new, Terraform search capability, I just want to start off by level setting and providing, a brief overview of, what is infrastructure as code? What are the problems that it addresses? And, for those of you who aren't too familiar with Terraform or the concept of infrastructure as code, like, what are we talking about today? So, the slide I have up right now pretty much describes the starting point for most of these organizations, most of these teams, right? Which is manual provisioning. Also, what we call ClickOps, right? You're clicking through cloud consoles, you're clicking through that Azure or AWS GCP console, you're running ad hoc scripts through the AWS CLI, and you're relying on that tribal organizational knowledge across your entire cloud estate for provisioning and managing these resources. So, I think, Ali, most engineers understand that, manual provisioning these resources, it's incredibly time consuming, right? Um, However, the real issue that's more impactful than just the manual provisioning, it's not just speed, but it's also the inconsistency that this manual provisioning creates, right? In terms of that infrastructure setup and management. We have lack of repeatability when we're doing this sort of click ops. And more importantly, we also have, a lack of audit trailing in terms of security. It's difficult to keep tabs on who did what to what at what time. Um, Essentially, at scale, this sort of click ops guarantees drift throughout your, infrastructure across all your cloud providers. And again, from the security and compliance perspective, if your infrastructure isn't codified, it's invisible, to your organization's policy and guardrails that you want to implement. So infrastructure as code flips that model, right? That's where Terraform comes in and allows your teams to describe the desired state of their infrastructure, right? Not the execution steps. Um, with infrastructure as code, version control becomes your system of record and source of truth for all of this infrastructure, right? So it essentially allows organizations to track infrastructure state and changes throughout that state over time, right? We're essentially writing our desired infrastructure configuration again in a codified manner instead of leveraging those, manual, error-prone ClickOps methodologies that I just mentioned previously, right? Now, whenever we make any infrastructure changes, this is all done in an automated fashion. And that's done by, leveraging Terraform's plan and apply runs, like we see in the slide here. What this accomplishes, it really removes that human error, again, manual processes, and allows us to be more consistent, predictable, and secure when we provision our workload or workflows, right? Um, and finally, another thing I want to mention down there, you'll notice all our multiple Terraform providers that we're seeing there. In this case, the Datadogs, the AWSs, GCPs, Microsofts. But these providers essentially abstract infrastructure complexity behind this consistent workflow, right? Um, when we talk about Terraform providers, they're really essentially plugins that act as a bridge between, Terraform and the external APIs of these cloud platforms, SaaS providers, other services, whatever we're deploying or communicating with. Um, they'll be essentially responsible for translating and exposing resources such as, your virtual machines, your databases, networking infrastructure, etc. Pretty much anything that Terraform can manage. And what this allows us to do is it allows us to manage infrastructure across multiple cloud and on-prem environments using a single consistent language across all of them. And we'll get into that right now in the next slide. Um, this common language is what we call the HashiCorp configuration language, or HCL for short. Now, HCL, as we see in the example here, I mean, it's very readable, right? And why do we care about this? This matters because it means that infrastructure is no longer a black box within a single platform team, for example. Your developers, your security engineers, your operators, they can all visualize what your cloud estate looks like and contribute to that landscape as well. Um, Another important item to note is, Terraform configurations are declarative and composable. What that means is you're essentially describing your desired outcome, and Terraform figures out how to achieve the end results. So, in the example we have here, we'll see that we have two resources that we're provisioning, right? We have those two resource blocks. The first one on the top, again, pretty. I'll kind of challenge you, Ali. Can you if are you familiar with Terraform at all, or is this the first time you're looking at Terraform code?
I don't know. I'm very familiar with it.
Yeah, so you can see what's happening here, right? Actually, I'll have you kind of give me an overview of what you think is happening here, just to kind of demonstrate how readable this is.
I mean, we define the resources, then we can just apply it,
Yeah,
basically.
right. So exactly. And in this case, I mean, just to go into more detail, the resources we're creating are the one on top of Google Compute instance, right? And we're specifying things like what name do we want to give that instance? What machine type do we want? Which zone do we want it to reside in? Um, what's some boot disk configurations, some parameters that we want to initialize? And on the bottom, we have a DNS record, right? What type of DNS record is this? It's an A record. What domain are we covering here in this record? It's example.com. So I just want to, demonstrate how readable, how easy it is to go through HCL, and it provides really that ease into looking into your organization's infrastructure. And again, just circling back to providers, another major benefit of leveraging HCL is that it becomes a common language across all these cloud providers. HCL is the same across all the 5,000 plus providers that Terraform supports throughout our entire ecosystem. So, just giving an overview of the benefits that we just went through, I think they're pretty well understood, but IAC brings versioning along with it, which essentially allows us, to track those changes over time with that human readable language. It increases the collaboration between our teams, right? Because now we have this centralized version control that enables our teams to, have that single pane of glass into the visibility of our landscape. It increases that consistency, replacing those, error-prone ClickOps, manual processes with predictable and secure executions that we just talked about, right? Um, it increases governance by, allowing you to codify the security compliance that's required throughout your organization. And finally, it increases that reusability of your code, right? You can modularize and create these Terraform modules to create that common, consistent workflow that can be reusable across teams. So now that we kind of have an understanding of what Terraform does, I kind of wanted to dive into what Terraform Search addresses, because in a perfect world, right, we'd have everything codified already, but that's not the case. I've never worked with a customer that had everything fully codified. It's usually kind of like a hybrid mix of, we provision some resources using ClickOps, we provision some resources using, the CLI, and then we provision stuff. When we started adopting IAC, we started using Terraform. That's when we started our IAC journey. So a huge issue that popped up was, how do we convert all this non-Terraform infrastructure into our codified estates? And that's where Terraform Search really comes in and directly addresses that gap that organizations see. So it's really designed for those environments where IAC adoption is partial, or where teams want to bring existing resources under management without months of manual efforts doing Terraform imports and stuff like that into, your Terraform states. So these sort of environments, it's what we, in this sort of issue is what we call the brownfield blind spot, right? So like I mentioned, most cloud estates are in that hybrid setups in terms of their IAC adoption. Some resources are in Terraform, some are not. And the resources that aren't in this managed state within Terraform, they create these three major risks, right? First one is they create a blind spot for compliance and security. You don't know what people are doing. You don't know what people are provisioning. Versus we just saw what Terraform brings to the table. You have everything in one place under your version control, GitHub, GitLab, whatever you use. Everything is readable. Everything is codified. You know what's happening within your infrastructure. The second issue that it brings is they'll add that operational overhead, right? So as your teams, they'll have to manually provision, manually manage the lifecycle of all this infrastructure. That adds a huge overhead to the administration portion of all of this, right? And finally, creating these resources manually will also contribute to configuration drift, right? Um, since there's no record of their desired state of your infrastructure, resources will naturally just drift from their intended state throughout their life cycle, right? As people make changes. And we care about this because this can lead to security vulnerabilities, right? This can lead to outages. It's these one-off changes that really create all these issues that we typically see. So before Terraform Search, the path to adopt infrastructure as code, um, in my experience and what I've seen throughout the industry, it typically involved, creating, spreadsheets, cloud inventories, a lot of manual efforts to transition these unmanaged resources into that state under Terraform. Um, in some cases, it was like weeks or even months of work to do this, and that's where most of the teams sort of kind of gave up on bringing their existing unmanaged infrastructure into a managed state. Now, that's where Terraform Search comes in. It introduces a new workflow that allows for the declarative discovery of these unmanaged resources across your public clouds, AWS, Azure, etc. Um, so instead of having your team manually hunting for these resources that are unmanaged, you're going to define a query. And that query is going to have what you want to find, and that's done by using a tfquery.htl file, and we'll see this in the demo. And that file, as we see here, contains, a list block. And within that list block, you have the defined arguments Terraform should use to perform the query. You can filter by, resource type, tags, region, instance sizes, whatever your use case is. Um, Then what's going to happen is you execute the Terraform query command, and that allows Terraform to query your providers and return matching resources matching the defined properties that can then be imported into your Terraform configuration. And again, like the example you see here, all of that is done using that same HCL syntax that your teams that use Terraform already know. They're already familiar with. They don't need to learn anything new. So in the example we have here, we're essentially saying, hey, we're going to use the AWS provider. I want to look into my AWS environment within the US East 1 region, and I want to look for AWS instances. I want to list AWS instances with the tag managed by with equals to none. So, even with ClickOps, you'll have teams leverage, tagging or they need to provision these resources with defined tag values. So a lot of the folks I've seen adopt Terraform Search leverage the tag method, but you can also filter by instance state name. Um, in this case, value equals running. So you can filter all running instances in the US East 1 region. Really, it depends on your use case. And we'll kind of dive into an example during the demo here. Now, before diving into the demo, I know I talked a lot, Ali. Is there any questions you want to ask, or should we just dive right into it?
Oh, let's just dive into it. It's very interesting.
Yeah, awesome. So for the demo, we'll be writing a simple TF query like the example we just saw. Then we're going to discover all these unmanaged resources leveraging this query that I defined. We're going to generate the Terraform configuration from those results and see how we can import them into my existing Terraform state um, in a matter of a couple minutes versus, prior to Terraform search, this probably would have taken me a few days to just manually find them, do some Terraform imports, go through the documentation, see what the requirements are for the Terraform import command, and we're going to replace that with a more automated, more consistent, and secure workflow to do that using Terraform search. So before diving into VS Code, I have one of my AWS accounts here, and I have these 6 unmanaged EC2 instances, and I just named them unmanaged instance appended with a number. But I provisioned these manually. I just came into the AWS console, I hit launch instances, and I just started manually provisioning these. Now, I want a smarter way to manage my infrastructure, and that's where I'm like, hey, I want to import this into Terraform and codify this. Um, so I can manage the life cycle of all this infrastructure, again, for that single pane of glass through version control. Um, these instances all have a tag um, managed by unmanaged, and we're going to see how we can import that into Terraform, change these values in a codified manner. And again, let's just dive into VS Code here. I have a very basic setup right now. Right. One thing I do want to mention again, this Terraform search capability came out in version 1.14. So I am telling Terraform to use, hey, I do require any version, 1.14 or above to use this. And we'll just verify that we are running version 1.14. And yeah, I do have 1.14.3. So I am able to take advantage of the Terraform search capability. Um, I'll just do a quick Terraform init, make sure my backend's initialized. Looks like everything is fine. And what we'll be doing is writing that query that I mentioned. So I'm going to create a new file. I'm going to call it search.tfquery.hcl. And this is going to be very similar to the example we saw in the slides. I'm going to create a list block, say AWS instance, because I want to find AWS instances. I'm going to make an easy name for this list block, unmanaged. And within this list block, I'm going to say, hey, I want to look into AWS by leveraging the AWS provider. Oops. And now I have my configuration block, and that's where I want to specify. In this case, I've only used the US East 2 region to provision these instances. So I'm going to specify, I just want you to look within US East 2. No need to go through all the other AWS regions, right? And now is where I define my filters. This is the important bit, right? Um, I'm going to give this one a name of, I want to filter by tag managed by. We saw that all of these resources had a tag managed by. And what do I want that value to be in my search? Unmanaged. So this, again, is going to go through all the instances within the US East 2 region, and it's going to find everything that has a tag of managed by with the value unmanaged. Um, we can create multiple filters, so I can go ahead and, make a second filter here. Let's say, what could we do? We could do instance state name, instance states. And what do we want? We want the values here to be, I just care about the machines that are running. All the machines that are off, they're probably going to be decommissioned. Just giving an example here. I just want to import the current running machines. So we have our TF query file defined here. So now all we have to do, and this is where the new capability comes in with Terraform Search, is we have a new command called Terraform Query. What this is doing, it's using that TF query.html file that we created. Oh, and I mistyped something. Let me just make sure I copy and paste the correct values and run it again. It's going to go through my AWS account in the US East 2 region, and it's going to find any resource matching the filters that I provided here. So we see here it did find those 6 unmanaged instances. It gives you information such as, account ID, instance ID, just to verify, hey, are these maybe, the correct instances that you're looking for? So we verified, yeah, these are the correct instances that we're looking for. So how do we import this into Terraform in an easy way? That's where we can leverage that same query command, but we can tell it to generate this output. And I'm going to generate this file called unmanaged EC2 instances.terraform file. And this, Ali, is going to be the file that provides all the Terraform code necessary to bring this into my Terraform state. So we still have the same output that we saw in the previous query run, but we also have this new .tf file. And you'll see here, this automatically generates the required AWS instance resources with all the required values, along with an import block for each resource to bring this into our Terraform state. Now, we still should go through the output that's generated here, and I already did that before, running this demo earlier today. I have this tf.working file. I just went through, and verified, hey, are there attributes that I want to remove? Like, I don't care about this IPv6 address count. It actually conflicts with this IPv6 addresses. So I remove that from all the resources. But another thing that I want to do as well, I want to make sure I change some of these tags, right? This Terraform is no longer unmanaged. So we want it to say in its tags that it's managed by Terraform. So that's one of the changes I wanted to do. I also want to call them, managed instance versus unmanaged instance. Like if I flip back to the AWS console, we see that their name are unmanaged instance and that they're managed by, unmanaged. So we want to change that. So after making the required changes, I'll just do a regular, Terraform plan. And it's gonna, if you're familiar with Terraform, it's gonna go through all the changes. It's gonna say it's gonna have 6 resources to import, 6 resources to change. That sounds about right. You can go over this, as you should do, your Terraform plans, make sure everything looks correctly, and then we can do a Terraform apply. We'll approve the apply, and done. Just like that, all these 6 resources that were previously unmanaged were now imported to my Terraform state. And then we can actually go to the AWS console, and I'll refresh here. We'll see that the changes that we made are present. So all these instances are now called managed instance with their number appended. And we can see here that they're now managed by Terraform. And now I shift from managing these resources throughout my cloud, you know, um, UI or even the CLI, and I can just manage this via code. So if I want to make any other changes, I mean, if I just want to, just a quick example here, I want to change the tag again for this managed instance 6 to Terraform 2. I'll just do another Terraform apply after making the required changes. It's going to tell me what those changes are. Hey, one of your resources that you're managing has a change. What is that change? You're changing it, your tags from Terraform to Terraform 2 within the that managed instance 6. We'll make the changes. Now, if we go again to the console to manage instance 6, we should see that it's managed by Terraform 2. Yeah, so that's really the bulk of my demo. Hopefully it summarizes, the value that Terraform Search brings to the table, the problems it addresses. But, just wanted to do a brief recap here of, again, how Terraform Search delivers this value. And it's essentially in these 3 layers, right? The first one, total visibility. Again, you have a single codified inventory of your entire cloud estate. And again, that's not just particular to AWS, it's across all your public cloud providers, your big GCPs, your AWSs, Azures, Ali Cloud, but across 5,000 plus other providers that we support. The second one is that automated import. We saw how Terraform can generate these configuration files for, the resources we want to discover, which dramatically reduces that manual work that comes along with Terraform imports or other workflows that you previously had in the past. And finally, again, it acts as a bridge to achieve that desired IAC outcome that your business wants to achieve. Organizations can modernize incrementally instead of having, to rewrite everything that they're doing from scratch. This allows you to kind of, work within that brownfield environment that's, probably present within your organization. And again, yeah, that's essentially it. Thanks again for taking the time today to dive into Terraform and Terraform Search and, learn on how you can easily bring this unmanaged resources into a managed codified state. I did write a blog post on this. Hopefully, we'll have it linked in the description. But yeah, Ali, I'll kick it over to you. Any questions you have?
Yeah, it was a very interesting feature. I mean, I heard that it was released on September, but I didn't have time to check it or the chance to check it. But now that you went an overview, I actually have like 3 questions. So, like, my first question is especially about the ClickOps part. So, can this feature be usable like after the import state? Like, can it discover the ClickOps or multi-state drifts? Like, okay, we had this Terraform, I applied it, then someone changed it from the like AWS UI. Can I just like keep running this step again and again to okay, you should copy this and paste it back to your resource?
So now that these resources that you imported are in a codified state, we have that state file with what our configuration should be, right? So if anyone were to like bypass any guardrails you have within your organization, were to manually make some changes, the next time you do a Terraform run, it would be like, hey, this isn't right. We need to apply the changes that are within code. And it'll overwrite the manual, changes that people made. And that's really one of the benefits of Terraform and infrastructure as code, right? It creates that consistency and eliminates that drift.
Uh, Thank you. And the other question was, since like this is stateless, like since this is only import state, like because there's no state yet, like I'm gonna use it for import. Is there also like a filter to like not tagged with to discover the resources that are also not compliant to a standard that I want to enforce?
Um,
Like let it be like a call center or something, like the as a tag.
yeah, you can definitely define that filter. It's very flexible. You can define whatever you want in that filter that meets your needs. I just use the managed by tag as an example because I see that in a lot of organizations, right? They have a tagging policy that folks need to follow. Usually it's tied to like a business unit or an application code, something like that, right? Um, that's a great way that I've seen people leverage this as of now, but there's other ways you can make your filters. It's really up to you.
Right. And my last question is, since this is like a fairly new feature, maybe this might be a bit like a more core part of the thing, but is this like the third party modules needs to be updated to support this, like a headsnet module or something, or this is like,
So yeah, I get what you're saying. This needs to be done. The changes need to be done on the provider side to be able to support Terraform search. So there's two key components here. Number one, you do need Terraform 1.14 or above. That is what enables you to use Terraform search. And then you need a provider that supports Terraform search. Now, currently we have AWS and Azure that have a couple resources that support Terraform search. And this is a new feature, and as this gets adopted and used, more providers will come into play, and more resources within these providers will be supported as well.
yeah. Thank you. Well, I think that's it for today's episode. See you next time, people. Bye for now.
Yep. Thanks, Ellie. Thanks, everyone.